Alright, so let's talk about half-life. Half-life can be used when you're talking about anything that's being decomposed. And like the other functions that we talked about, A stands for final value, P is the initial value, and T is for time. But now that we're talking about half-life, there's a variable H that stands for half-life, and the base is going to be a half. This is a split factor, meaning like if something is a pound, when it's at half its life, it's a half, and so that's where that comes from. But let's actually apply it. So in the first example, we have that chromium-51 has a half-life of 27.7 days. It says how much of 3 grams of chromium-51 will remain after 90 days. So let's fill in the given information that we know. Since the question states how much chromium will be left, we know that we are looking for a future value. And our principal amount is 3, so we have 3 grams in the first day and after 90 days. So our T is 90, and our half-life we know is 27.7. So let's just plug this into the formula. So we're going to have A is equal to 3 times 1/2 to the 90 over 27.7. And let's put this into our calculator. Remember that to get to the little fraction, you can hit second alpha y equals and click enter. And this is approximately equal to 0.316. So the first one wasn't too bad. Let's try another. An isotope decays within 20 hours from 5 grams to 2.17 grams. Find the half-life of the isotope. So this time they're telling us that they want us to find the half-life. So we're looking for the half-life. It's telling us that we had 20 hours. So that was 20 hours. And our grams, it was initially 5 grams and it decayed to 2.17 grams. Okay, let's plug it in. So we have 2.17, which is equal to 5 times 1/2 to the 20 over h. And now let's solve for h. But where's the h? That's in the exponent. So we're going to want to try to isolate the half raised to the 20 over h. So we have to divide by 5 to both sides. 2.17 divided by 5, that's 0.434, which is equal to 1/2 to the 20 over h. And since we have an exponent, we can do the ln. We can take the ln of both sides. So we have the ln of 0.434, and then remember that the 20 over h comes up front, ln of 1/2. And so since we have multiplication going on between the 20 and the h, we can just rewrite that on top. So we have 20 ln of 1/2 over h times ln is equal to ln of 434. So all I did was multiply 20 times ln and brought it up front. And now that we have a denominator on the h, we can always rewrite the ln with a denominator as well. We can rewrite that over 1. And from here, what we can do is just cross multiply. So we can cross multiply and get, so we have h times ln of 4.434 equal to 20 ln of 1/2. And now from here, just divide by ln 0.434 to get h by itself. So divide by ln 0.434 and then plug this into your calculator. So h is approximately equal to 16.6 hours. For this last example, the unit was grams because we were talking about how much it would decay to in the future. You will often run into problems with carbon-14 half-life problems in Half-Life, so you have to remember that it has a half-life of 5,730 years. So let's do an example with that. It says that a dead tree trunk has 86% of its original carbon-14. Approximately how many years ago did the tree die? So we don't know the original amount, so we're going to use P. And since the future value is 86% of the original value, we're going to take 86%, turn that into a decimal, and multiply it by p, because that is how you find a percentage of something. And the half-life of carbon-14, as we said, was 5,730, and we are looking for how many years ago that happened, so we're looking for time. So if we just plug everything into the formula, we get this. And remember that we want to try to isolate the term with the variable exponent. So we want to try to divide by p to both sides to cancel out the p's. And then we're left with 0.86 is equal to 1/2 of t over 5,730. So we can take the ln of both sides. So we take ln of 0.86 is equal to the t over 5,730 comes up front, ln of 1/2. So at this point, this is algebra, and we're just trying to solve for t. So we can just divide both sides by ln of 1/2. And there are many different ways of doing this, but this is one way of solving for t. So you can divide that out and get that t over 5,730 is equal to ln of 0.86 over the ln of 1/2. And now just multiply 573 to both sides, so you get that the ln of 0.86 times 5,730 over the ln of 1/2. And now just plug this into your equation. Calculator. So t is approximately 1,247 years ago. So this tree died that many years ago. Alright,